السلام عليكم، يعطيكم العافية. معكم هناء ذيابات، سينيور داتا ساينتست من بيوند ليميتس. سمعنا كثير عن تطبيقات على كيف الويذر فوركاستينج، فاليوم حنركز على التايم سيريز اناليسيز. سمعنا كيف عم تطبق، بس خلينا نشوف الكور، خلينا نعمل ستدي هيك. خلينا اليوم نعرف إيش هي التايم سيريز. كونه شفنا الويذر داتا هي مش ستاتيك داتا، هي بتعتمد على داتا مثل ما حكى الأستاذ محمد، داتا من الباس على الترندز كيف كانت من زمان. فهاي إشي اسمه kind of data اسمها time series data. خلينا نعمل اليوم نشوف شو هي، ليش بدنا ندرسها. نجرب. خلص تمام. اوكي يسلمي. هيك صوت واضح؟ تمام. حنتعلم ايش هي التايم سيريز، ليش راح نتعلمها، حنشوف كيف احنا نشوف التايم سيريز، كيف نطلع منها انسايتس، وحنشوف كيف التطبيقات عليها. لا هيك. اوكي، حدا سمع ايش هي التايم سيريز؟ حدا مر عليه kind of data بس تكون تايم سيريز؟ ما في حدا، صح؟ طيب تمام، معناته ممتاز. تايم سيريز هي عبارة عن داتا أو collected data، بس بهمها إيش؟ إنها هي collected in order، يعني هي temporal إيش؟ معتمدة على التايم. يعني أنا ما بقدر أحكي إنه والله عندي هاي مثلا temperature اليوم، بقدر أعمل forecasting للتمبريتشر بناء بس مثلا على الداتا لليوم. لا، لازم أعرف كل الداتا إيش باللي قبل. ليش؟ لأنه التايم سيريز داتا هي أي داتا influenced by الهيستوريكال داتا إلها. طب خلينا ناخذ example، يعني خلينا نفرق يعني كيف. يعني مثلا تايم سيريز داتا مثل ما حكينا التمبريتشر، أنا ما بقدر أعمل فوركاستنج للتمبريتشر اليوم بس بناء مثلا على المكان اللي أنا فيه، مثلا بناء على الجيولوجي وهي الأشياء ستاتيك داتا لليوم. لا، لازم أعرف كل الترندز اللي صارت بالباست. مثال ثاني مش تايم سيريز، نون تايم سيريز داتا، اللي هو مثلا مثال خلينا نعمل بريدكت للرانكينج لل يونيفرسيتي. إذا بدنا نعمل هاي الشغلة ما بهم بأي وقت بأي زمان، بيعتمد مثلا الرانكينج على إيش؟ على الريسيرش اللي طالع من هاي السكول، على مثلا شو الجراجويت، عدد الجراجويت. بس هون إيش؟ ما بيعتمد على التايم. طيب ليش نحن بدنا نتعلم أو بدنا نعمل ستدي للتايم سيريز اناليسيس؟ لأنه مثل ما شفنا أول إشي هي موجودة أو كومون بأغلب الفيلدز اللي احنا بنعيش فيه. مثال الأول اللي كنا حكينا عنه الويذر، مثال الثاني الفاينانس. في أغلب الناس إيش بالفاينانس عم تعمل ستدي للستوك برايس. يعني الستوك برايس الآن أنا ما بقدر أعملها فوركاستينج مثلا بالفيوتشر بدون ما أشوف الترند، بدون ما أشوف كيف كان مثلا الستوك in past مثلا 5 days، ممكن 5 months، أو مثلا أكثر من سنة. أنا إذا عرفت مثلا هاي الترندز بقدر أعمل فوركاستينج مثلا للستوك برايس لبكرة. ممكن تكون فايدة بالإيكونوميك أو بالبزنس. مثال ذلك خلينا نشوف مثلا أي ويب سايت أنا بدي أعرف كم مرة فات يوزرز على الويب سايت. عشان أنا ما بقدر بس أعرف إنه والله كم مثلا كليكس بدون ما أعرف كيف البيهيفير لليوزر بالباست. طيب التايم موتيفيشن للتايم سيريز، أنا إيش بقدر إذا كان عندي تايم سيريز بقدر أشوف الترندز الباترنز بالداتا، بلس بقدر أعمل فوركاستينج أو مونيتور للداتا. ناخذ هذا الإكزامبل. هذا الإكزامبل بوضح لنا كيف إحنا رح نعرف or identify patterns بالداتا. هاي الداتا هي daily climate time series بإنديا. حيوضح لنا هون في عندنا temperature، الهيوميديتي، وفي الويند، وهاي البريشر. مثل ما احنا شايفين انه التمبريتشر، يعني كيف هون عرفنا البترن مباشرة بالتمبريتشر انه هي it's the lowest مثلا value بجانيوري. كنا بنعرف بالوينتر حتكون درجة الحرارة كثير قليلة. بعد هيك it will increase up، مثلا البيك تاعها حيكون بالسمر then decrease. So for 1 year we know now the pattern of behavior la temperature. Similarly for the humidity it's also wow. Okay. شكرا. Similarly for the humidity, if you can see here, it's it had the highest value in January بالwinter and then decrease till July and then increase till the next year. So we have a pattern for 1 year. From here we can also see a relation between temperature and humidity. So for a value, increasing value for the temperature from January to July, it corresponding to a humidity highest value in January, then a decrease in July. So from time series analysis, we can see or identify the pattern and relationship between data. Okay. Next, we can also talk about the forecasting the values. So for the time series, we can also have or know, we need to know or predict and value in the future. ماشي؟ بس لازم كمان احنا نعرف مثل ما حكينا مثلا لازم نعرف ال values in the past or historical data. This figure show a forecasting housing price week by week in New York City. Let's have an example. Commonly in time series, we need to set a window in the past for the historical data that we need to depend on in the future forecasting. So if we take this example, we need to forecast a value in 2006. Then we need to know, if we assume the future window is for 2 years, if we need to forecast a value here, we need a window from the data from here to here, 2 years. So that's called the forecasting for time series. Okay, we know now what the motivation to study the time series. So let's know some principles, go deep to the principles and component of time series. Yeah, first of all, let's talk about the time series component. مثل ما احنا شايفين هاي time series، تمام؟ بس هل can you find patterns from this, or it have also a complex figure or curve? It's really complex to get the patterns or relationship from this figure. So what we need to do is to break down this time series into 3 components. The first, it's the trend, seasonality, and the residual. Let's go to here. So this time series is a collection of these 3. So if we merge these, we will get this. But If we know this component, it gives us easily understand the data. First, it has a trend. A trend is something called a long-term direction. So we know that's the curve or the data, it's increasing over time. From the seasonality component, which is, it is a periodic behavior, we know that there is up and downs on a fixed interval over time. And this is the fluctuation, which is after extracting the trend as seasonality, we will get the fluctuation, which called the residual. So, now we can see it's really easy to understand the data if we break it down to its component. And also, from a statistical way, if we need to model this curve or this time series as it's really complex. However, it's really easy to model these components, each one separately. Let's study each component trend. As we see, the trend is a long-term increase or decrease in the data. But this also trend or this increase or decrease, it has two types. The first type is it a linear or exponential? So the linear, that's mean, we can see here, the linear, that's mean it's increase in a steady rate. For example, the temperature, كنا بنعرف إنه التمبريتشر بتزيد بس اليوم عن past century it's really فرق بين ال two values صح؟ لكن هل صار مثلا هاي القفزة بيوم وليلة؟ لا، كانت كل سنة أو كل century عم بتزيد بريت معين. And that's called linear. Exponential, no. Its rates have some jumps or downs once. So it have, like this. For example, كنا بنعرف فيديوهات اللي على التيك توك وهاي الأشياء، أي حدا ممكن ينزل فيديو ما يكون عليه فيوز. فجأة صار في ترند، صار في عندي exponentially إيش رايز مثلا لهاي الفيوز على الفيديو. Okay, next component is seasonality. Seasonality from this figure, it's called pattern. But this pattern refers a long-term pattern, and also it's repeated, occurring over a fixed interval. We can't say that this is a seasonality, but it have repeated behavior this year and next year, but it doesn't happen after that. No, we can't say this because the seasonality should be repeated patterns on a long period. Okay, we see that seasonality is something goes up or down or pattern happen into the time series. But what causes this seasonality? What caused that this value at this time it's high, but next it will be low? For example, when we take the temperature, we see that the temperature it's low in winter but high in summer. So one reason could be a natural factors. If we take also the temperature as example, we know that for natural factors, because sunrise, sunset, that cause the day-night, we have the temperature low at night and then have the peak in the noon, and then it will decrease. Second, it could be a social actions. So if we take example of sales, everyone know that the sales could really affected or influenced by the holidays. So for this example, if we take this figure, This is a guideline from Google ads to their users to know when their ads will be at peak points. So it will show how the seasonality or the patterns of having or raising the clicks on their products. So we know that the sales will be increased at some holidays, and also have one of these holidays, maybe Christmas or New Year, it has a peak. So are you now know what's caused the seasonality? It's okay from everyone?
Yeah.
Okay. Then, okay, so we know that the time series, it has 3 components, which is the trend. If we break it down to trend, to seasonality, so if we break this or subtract these 2 patterns from the sales or from the time series, we will have remaining part. The remaining part called residual. Residual is something, fluctuation that's come after you subtract the trend and seasonality from the time series. Okay, now we know that we know the component of time series, but how we can break it down? We will break down this time series to its original component, 3 components, by doing a decomposition models. Decomposition models are really effective of breaking down the time series. As we said earlier, that the time series as it is, without breaking it down, it's really hard to understand the patterns or to understand the behavior of the time series. Also, it's really complex to any model or statistical model to modelize or to model a time series like this. So if we break it down to 3 components, we can easily model each component separately. Okay, so we have these components, but how they are aggregated to have the original time series? That's done by the decomposition model. Decomposition model done by 2 types. It's additive model or multiplicative model. So that's mean we have these components. Do we need to sum or add these components together to get this the time series, or do we need to multiplicate these components to get the time series? So that's called the decomposition models. So the first type is additive model. The additive model, it has some probability. The first probability is the seasonal or the seasonality and the trend component are really constant over time. And also the magnitude, you can see it here. If we can see the seasonality, it's really what's constant over time, and also the trend is constant over time. The second part is the magnitude of these. The magnitude of this fluctuation. It's not a fluctuation, it's the seasonality part. These are constant over time, as we can see. So that's called additive model. The additive model, we can see it, the seasonality trend are constant, and also the magnitude of this fluctuation are still constant or equal over the time. Finally, if we need to get the original time series, we will add these components together to get the original dataset. Then the multiplicative model, it's the opposite of the additive model. That means that the seasonality and the trend components are varying over time, plus the magnitude of this fluctuation are also change over time. So if we see here, this fluctuation are really smaller than this over time. Yeah, we can see here how it's the magnitude of this fluctuation are varying over time. So we will multiply this component to get the original time series. Let's go over. This figure will show clearly how these two models are different. As we can see here, the additive seasonal or the additive model that show how the magnitude of seasonality fluctuation are constant over time, and in the opposite here you can see how the fluctuation of the seasonality are varying over time. So, if we need to do it on Python, there is state models library have my statistical models. One of the models is the TCA, which is the time series analysis. You can use the seasonal decompose method, and you can explicitly identify the model if it's multiplicative or additive, and it will easily break it down the time series to 3 components like this. Okay. Then another principle in time series that's called the stationary time series. What is the stationary time series? The stationary time series is a time series that have a fixed statistical component over time. What's that mean? If we can see here, stationary, that means it has a constant mean, constant variance, all of these. If we can see here the stationary series, if we can, this is a time series. You can see the blue line is the mean over time, it's constant. And also the variance for the data over the mean have a lower and upper limits are fixed over time. So this is called a stationary time series because it has constant mean variance over time. However, if we can take this example shows that the blue line, which is the mean, it's really varying and increasing over time. So this will break one of the rules of stationary time series. So we will call this stationary time series. However, for the can you hear me? The next figure shows that the blue line, which is the mean, is constant. However, the variance, the data, how they are vary from the mean are varying over time. So that's called a non-stationary time series. So why do we need, or for that, a stationary mean that if we move this time series over time, we will get the same probability or the statistic for this time series. So that gives us why it is the time series is really important in statistics, because first, if we know the statistical variety of some data, if we know the average or the mean, the variance, we can easily predict the data. So if we know the mean, we can easily know that the data after this time can be varying between the mean, and also we can know the data will not go over the variance. It will not go before the upper limit, or it will not go under the other limits. Yeah, and that's it, yeah. So if we have a stationary or non-stationary time series, we can easily, as we know the decomposition model, we can easily break it down and get the residual. So we will here we can see that the time series, if we remove the trend, remove the seasonality by components, we will get the residual. So for this one, this is a non-stationary model because the mean is really varying over time. Plus, this is will not. So having the residual is called a stationary model. So now we know what is the time series, then we know the components of the time series. Now let us go and proceed to know how we can process this data. First of all, let's see the smoothing technique. Smoothing technique called, or it's used to remove any noise, the noise that's called a short-term change in the data. So if we can see here, let's see here. If we can see here that we have this data, the original data, this the noisy data, and we have some spikes are really short. We can say this spikes is a seasonality of the data because seasonality should be a repeated pattern in a long-term period. So these spikes are noise. Smoothing techniques can easily removing these noises. So if we can see the smooth part, which is this line shows the smooth time series. As we can see, the noise will be removed, plus the data now, it can easily to identify it. We can easily see the seasonality without having these spikes on it. So, if we need to do a smoothing techniques, we have two types. The first one is moving average, and the second exponential smoothing. Moving average, from its name, is just replacing or forecasting the data by the averaging data in the past. Let's take this example. If we need to do a moving average for the points from here and from here, so we need to know first the window. So we need to average the data before this point. But so one principle from moving average, we need to know how many points you need to average, which is called the window. So for this example, this value is averaging these values. Averaging is just summing these values and dividing them by 6. Then for the next value, which is here, we need to move the window like this. So we need the 6 values before this point. To go on is just, that's why it's called moving average. We need for each time you get the averaging for one value, you need to slide the window until you make the averaging for all data. So having this data here, this is just for visualization. Okay, but these the smooth values. as we can see them here. Okay, the second technique from smoothing is exponential smoothing, which is a part of moving average, but here it's a weighted average. What's that mean? That means if we, in the previous example, we take averaging for the 6 values equally, just sum them and dividing them by 6. However, here no, we need to give a weight for each value. And exponential smoothing that assigns for each observation a weight that exponentially decreases as it gets older. If we can see here the example, if we can see this is the example. At this point, if we need to get the exponential smoothing for at this point, we need to give weights for all these values or the window that we have, and the weights will decrease over time. So as you can see, it will decay over time. Okay, let's go over something called a metric. So if we need to use the exponential smoothing or the moving average for time series processing, we need if we need to use them as forecasting. For example, we need to know which model is better. We need a metric. We need a rule. So the metric called something can you rely on to say this model is better than this or not. How we can get this? By one of the metrics for time series, which is the mean square error. It's the mean of all errors for all samples. If we can see here, the blue curve is the actual data, and this line is the forecasting data. What's called error for each sample? The error code is the difference between the actual data and the forecasting data. So summing these differences, that's called the root mean square. And if we have a model have a mean square error 10 and other model have mean square 100, so we can say the model 1 has a lower mean square, which is, we can adopt the first model because it has a lowest error. I see that I will skip this part, because Mohammed Shakir said everything over this, but we can just look over this. We know the importance of weather forecasting, as he said. We know how the data are collected, and here I just explain how the time series, what's components that make you easy to identify the patterns. You can easy to study the time series for weather forecasting. And he also mentioned the limitation and challenges for weather. Finally, this is a first step to study a time series. It's first step because now you know what's the time series, what's its component, what's the difference between stationary and non-stationary.